Hi everyone, my name is Amitish, and in this video we're going to prove the derivative of sine is cosine and the derivative of cosine is negative sine right from the definition. So this video is going to be good practice with the limit definition of the derivative, good practice with trig functions, and good practice with thinking mathematically and going beyond just simply applying formulas and memorizing derivatives. We're really going to understand this, and I'm going to explain this to you. As I've taught multiple times at Princeton University in freshman calculus, I've received a university-wide faculty teaching award at Princeton. I'm a research mathematician. I think a lot about advanced math research and math problems, and I'm going to show you how to think about this in a unique way. So let's dive into it. Derivative of sine x is cosine x. How does this work? So the limit definition of a derivative is limit h goes to 0 of sine of x plus h minus sine of x divided by h. Okay, so that's all there is to it. We just need to take the limit definition of a derivative and work this out. Now the cool thing about sine is that it has these nice properties with respect to addition. So sine of x plus h can be figured out. This is a trig identity. Okay, so what is sine of x plus h going to be? Well, sine of x plus h we know, so I'm just going to write this on this side of the board. This is a trig identity. Sine of x plus h is going to equal to sine x cosine h plus cosine x sine h. Now, this can be proved right from the definition of sine and cosine using right triangles, but that deserves a separate video. So assuming that, how are we going to go forward? So now we just, keep simplifying the limit. This is a 0 over 0 limit. Like any limit definition of a derivative of a continuous function, as h approaches 0, you have 0 on the top and 0 on the bottom. So what you really need to do is kind of cancel something off from top and bottom. So let's first try to simplify this the following way. So sine of x plus h, we can apply what we saw on the right side of the board. It's sine x cosine h plus cosine x sine h minus sine x divided by h. Okay, so that's what we get. Now, when we have a limit like this, where we're adding up and subtracting a bunch of terms in the numerator, you have to be very careful that you can't just split it up into three different limits. For example, if you just took the negative sine x over h, well, as h goes to 0, negative sine x may be a non-zero number, you're going to get something non-zero over 0, which is going to go to plus or minus infinity. So you can't really do arithmetic like that. You have to make sure each limit exists before you split it up as a sum or a difference. So what we can do here is try to factor stuff. Okay, that's always kind of the standard approach with math, with algebra, with calculus, is factor things from the top. So you can factor out a sine x. You've got two sine x terms. So what you can do is you can say this is limit h goes to 0 of sine x times cosine h minus 1 plus cosine x times sine h divided by h. Okay, now here I want to pause a second and just draw attention to the fact that x is a constant in this limit. Okay, so we're taking a limit as h approaches 0, x is a fixed point. Okay, so we're differentiating at x, right? So x is a constant in this limit. For example, if we're differentiating at 5, then x would be 5, it's a constant, h is going to 0. So we can sort of factor out the sine x and the cosine x. We just care about the h terms, and here you kind of get into something which is the sine h over h and the cosine h minus 1 over h. Now I've done a video on sine h over h. It's a fundamental trig 0 over 0 limit. Okay, so I've done a video where I prove it rigorously. Check it out, links on my channel, links in the description, where I prove that limit h goes to 0 of sine h over h is equal to 1. Okay, so this is a fundamental limit. It's a 0 over 0 limit, and it's actually so cool that any trig 0 over 0 limit, if you can write the trig function in terms of sine, which you always can, even cosine can be written in terms of sine, then what you can do is you can apply this limit here. Okay, and we're going to do that in the following limit. We're going to apply that limit there, and as I said, I've proven it in that video, but we're going to apply it, and we're going to get, factor out the sine x and the cosine x because they're constants in the limit. So we get sine x times limit h goes to 0 of cosine h minus 1 divided by h plus cosine x times limit h goes to 0 of sine h over h. Now, if you do this kind of, this kind of expression, you know that limit h goes to 0 of sine h over h is 1, as we saw. Limit h goes to 0 of cosine h minus 1 over h is 0. Now, I'm going to explain at the end of this video why that comes from this limit. Okay, so just bear with me, assume that for the time being, or you can skip to the end and come back and watch this if you want to see that derivation right now. But knowing that this limit is equal to 0 and knowing that this limit is equal to 1, you get the final answer of just cosine x. Okay, so that's going to be the limit. That's why the derivative of sine x is cosine x. So that's the first argument. Now we're going to go on to the second, which is why the derivative of cosine is negative sine. And this is going to be very similar. So I encourage you, with math, it's not just listening. If you like to listen as entertainment, I encourage you to do that. I'm really happy to support you and to kind of keep these videos as an entertainment. But I also recommend, thinking about it now. Now that you've seen this, how are you going to do the derivative of cosine straight from the definition? Okay, so I'm going to erase this all off from the board, and it's going to be very similar but using a different identity. Okay, so practicing it is really important because sometimes, it's easy to think you sort of know what the process is, but when you kind of go through it, you realize there's some things that maybe didn't occur at the beginning. So I think it's very helpful to practice these things, but let's kind of just work it out directly now that, assuming you've paused the video and thought about it, or if not, you're just enjoying the process of me doing it. Let's go into derivative of cosine x. So limit definition of a derivative says it's limit h goes to 0 of cosine of x plus h minus cosine of x divided by h. Now again, we're going to use a trig identity. So cosine of x plus h is the trig identity, and this is an identity which is looks a bit different from sine, but it's basically saying that cosine of x plus h is equal to cosine x cosine h minus sine x sine h. Okay, so that's going to be the trig identity. So again, it's the same thing. So I'm going to walk you through the steps again to really reinforce them. So what are the pitfalls we have to look out for? So we've got limit h goes to 0 of cosine x cosine h minus sine x, and then we're going to subtract off the cosine x. Okay, so sine x sine h minus the cosine x divided by h. Now again, you can't sort of take the cosine x separately and divide by h. You have to factor out and get two terms, both of which a limit exists, before you can split a limit of a sum as the sum of the limits. So here what we can do is we can do that factoring out. So we get limit h goes to 0 of cosine x times cosine h minus 1. Okay, so cosine x factors in two terms. So times cosine h minus 1 divided by h. If you factor out the sine x, you get sine x times sine h divided by h. Okay, so that's going to be the limit, and now you can find out each limit separately. Okay, so again, you could split it up into two limits. So here, using the fact that I mentioned that cosine h minus 1 over h goes to 0 as h goes to 0, and using the fact that sine h over h goes to 1 as h goes to 0, you've got basically a cosine x times 0 minus sine x times 1, which is just going to be negative sine x. So that is going to be the derivative of cosine x is negative sine x. So that's the derivation of this limit. Now I'm going to end by explaining why the cosine h minus 1 over h is going to be 0. And this is super important. It shows you, it gives you one example of why any trig 0 over 0 limit can be ultimately reduced down to the sine h over h limit, which is the fundamental trig 0 over 0 limit. So as I said, check out my channel. I've got lots of infinite free accessible math education at all levels of math, many different levels. If you have kids, your friends have kids, you know people who are just trying to learn creative math thinking, I've got videos in basic math, advanced math, proof-based math, college math, high school math, all levels of math. So check out my channel, and if you're enjoying my content and find it valuable, please don't forget to like and subscribe. I'll show you now the cosine h minus 1 over h, and I've done another video on my channel where I've demystified any trig 0 over 0 limit, a magic spell for any trig 0 over 0 limit using the sine h over h, okay? And this is going to be an example in the same style. So limit h goes to 0 of cosine h minus 1 over h. Okay, this is a 0 over 0 limit, first to verify, that as h goes to 0, cosine h goes to 1. So you get 1 minus 1 on the top, and you get, which is 0, and you get 0 on the bottom. So it's 0 over 0. Now how do we reduce to the sine x over x, so the sine h over h limit being 1? Well, what we want to do is we want to use some trig identity. If you've seen, I have a video, the secret trick for any radical limit. We can use the difference of squares formula. I've done it in that video. That was pretty popular on my channel. You can check it out. We're going to do the same idea here. We're going to multiply top and bottom by cosine h plus 1. Okay, so this is the conjugate of cosine h minus 1 if you like. So we get cosine h minus 1 times cosine h plus 1 divided by h times cosine h plus 1. And the idea here is that we're going to make everything in terms of sine. Okay, we're going to get the top in terms of sine. So cosine squared h minus 1, right? It's a minus b times a plus b formula. So you've got like a minus b times a plus b, we know that a minus b times a plus b is a squared minus b squared. So because of that, we can apply that formula and use the trig identity that sine squared h plus cosine squared h is equal to 1 to deduce that therefore the numerator of this expression is going to be limit h goes to 0 of cosine squared h minus 1 squared, right? Cosine squared h minus 1 squared, which we know is equal to sine squared h plus cosine squared h. Okay, so it's going to be cosine squared h plus sine squared h, and that's going to be whole divided by h times cosine h plus 1. And now we're almost there. Okay, so we're going to somehow eliminate the 0 over 0, isolate it using the sine h over h. Okay, so that's why I say it's a magic spell, because the 0 over 0 part is going to be abstracted out as that limit, and the rest we'll be able to calculate. So now let's work that out. So I have proven these derivatives. This was a theorem. And what we did was a mathematical proof. You know, we used several lemmas. We used the derivatives. We used these addition formulas for the angles of sine and cosine. But once you have those, you can, derive that. And the sine h over h, which I've proven in another video. But down here, we now get this is limit h goes to 0 of cosine squared h minus cosine squared h plus sine squared h is negative sine squared h divided by h times cosine h plus 1. Now I want you to pause for a second and see how to find that limit, knowing that sine h over h is 1. Okay, so the way I think about it is, even if we did not know sine h over h approaches 1, we sort of think about where the culprit is. Okay, it's a 0 over 0 limit. The top and bottom are 0. What are the culprits for the 0 over 0? So the way I like to think about it is, okay, the h is a culprit, but cosine h plus 1 is not going to 0 as h goes to 0. Cosine 0 is 1, so it's going to 2. And then on the top, the sine h, or the sine squared h, is a culprit. So if we can abstract that out and we know that limit of that 0 over 0 limit, we can figure out the rest. And that's what we're going to do. So we're going to, and watch till the end, because I'll give you a quick challenge which will really help practice, and it's a really important limit to know. Okay, so watch till the end for that. But here we're going to get limit h goes to 0 of sine h over h times negative limit h goes to 0 of sine h over cosine h plus 1. Okay, and now you see that the sine h over h is 1. So that's the 0 over 0 that we may not know. That was a black box for us. But we sort of figured out that is approaching 1. And then the sine h over cosine h plus 1, well, the bottom is not approaching 0. That's the crucial thing. So we're not dividing by 0. A bottom is approaching 2. The top is approaching 0. So we get 1 times 0, which is equal to 0. So that is going to be the limit of, cosine h minus 1 over h. It's going to be 0. And the limit I'm going to ask you, which is a quick sort of challenge question, what is the limit as h goes to 0 of cosine h minus 1 over h squared? Okay, not over h squared. So this is going to be something interesting. And the reason I say it's important is because it sort of corresponds to the Taylor series of cosine. And if you end up studying that, or trying to understand higher derivatives of cosine. Okay, so thank you so much for watching. I hope you loved that video on the limit definition of a derivative for sine and cosine. And check out my channel. As I said, I'm trying to help as many people as possible with infinite, elite, free, accessible math education. I try to present math as a journey rather than as just here's a concept, memorize it. I try to show you how to think about it, how to understand what to look for in problems. Like we did here, I sort of showed how to look for the 0 over 0. And my channel has content at all levels of math across all concepts. I upload very regularly, 5 videos a week is my goal. And if you check out my channel, there'll definitely be a lot of stuff for you no matter what level of math you're at. So please do that. Please like, share, subscribe, share with friends and family. Anyone can benefit from my channel, no matter their math level. And I wish you all the best. I'm super excited to see you in the next video. Please take care. Drop me a comment down below how you'd find that limit over there. And I'd love to hear your comments on that. Or if you have any other thoughts, comments, feedback, or questions, I'd really love to hear it. I'm super excited to see you in the next video.